Good day, everyone. I am Rejoice Gundayao, the second reporter of Group 6, Chapter 11, Single Server Waiting Line Model with Poisson Arrivals and Exponential Service Times. So, in this section, we present formulas that can be used to determine the steady state operating characteristics for a single server waiting line. The formulas are applicable if the arrivals follow a Poisson probability distribution and the service times follow an exponential probability distribution. So the following formulas can be used to compute the steady-state operating characteristics for a single server waiting line with Poisson arrivals and exponential service times, where lambda equals the mean number of arrivals per time period, the arrival rate, and the mean equals the mean number of services per time period, the service rate. The first one is the probability that no units are in the system. So P sub 0 equals 1 minus the arrival rate over the service rate. The second one is the average number of units in the waiting line. L sub Q equals arrival rate squared over service rate multiplied by service rate minus arrival rate. The third one is the average number of units in the system. L equals L sub Q plus arrival rate over service rate. The fourth one is the average time a unit spends in the waiting line. W sub Q equals L sub Q over arrival rate. The fifth one is the average time a unit spends in the system, when W equals W sub Q plus 1 over service rate. The sixth one is the probability that an arriving unit has to wait for service. So P sub W equals arrival rate over service rate. The last one is the probability of n units in the system. P sub n equals arrival rate over service rate to the power of n multiplied by P sub 0. So these equations are applicable when the service rate is greater than the arrival rate. So if this condition does not exist, the waiting line will continue to grow without limit because the service facility does not have sufficient capacity to handle the arriving units. Recall that the Burger Dome problem we had an arrival rate of 0.75 customers per minute and a service rate of 1 customer per minute. Therefore, P sub 0 equals 1 minus arrival rate over service rate equals 1 minus 0.75 over 1 equals 0.25. L sub q equals arrival rate squared over service rate multiplied by service rate minus arrival rate equals 0.75 squared over 1 multiplied to 1 minus 0.075 equals 2.25 customers. L equals L sub Q plus arrival rate over service rate equals 2.25 plus 0.75 over 1 equals 3 customers. W sub Q plus L sub Q over arrival rate equals 2.25 over 0.75 equals 3 minutes. W equals W sub Q plus 1 over service rate equals 3 plus 1 over 1 equals 4 minutes. P sub W equals arrival rate over service rate equals 0.75 over 1 equals 0.75. The results. First is the customers wait an average of 3 minutes before beginning to place an order, which appears somewhat long for a business based on fast service. Second is the average number of customers waiting in line is 2.25. Third, the third is 75% of the arriving customers have to wait for service. Then the last one is there is a 0.1335 probability that 7 or more customers are in the Burger Dome system at one time. So these are indicators that something should be done to improve the waiting line operation. The decision of how to modify the waiting line configuration to improve the operating characteristics must be based on the insights and creativity of the analyst. Burger Dome's management concluded that improvements designed to reduce waiting times were desirable. To make improvements in the waiting line operation, analysts often focus on ways to improve the service rate. Generally, service rate improvements are obtained by making either or both of the following changes. So the changes are the first one, increase the service rate by making a creative design change or by using new technology. Second is add one or more servers so that more customers can be served simultaneously. Burger Dome's management decides to employ a design change that allows the customer to fill out and submit a paper order form directly to the kitchen while they are waiting in line. This allows the customer's food to be ready by the time the employee collects payment from the customer. With this design, Burger Dome's management estimates that the service rate can be increased from the current 60 customers per hour to 75 customers per hour. Thus, the service rate for the revised system is a service rate equals 75 customers divided by 60 minutes equals 1.25 customers per minute. The new operating characteristics are probability of no customers in the system is 0.400, average number of customers in the waiting line 0.900, average number of customers in the system 1.500, average time in the waiting line 1.200 minutes, average time in the system 2.00 minutes. Probability that an arriving customer has to wait 0.600. Probability that 7 or more customers are in the system 0.028. So the average time a customer spends in the waiting line has been reduced from 3 to 1.2 minutes. The average time a customer spends in the system has been reduced from 4 to 2 minutes. So the added cost of any proposed change can be compared to the corresponding service improvements to help the manager determine whether the proposed service improvements are worthwhile. Another option often available is to add one or more servers so that orders from multiple customers can be filled simultaneously. That's all.